is a vessel contains 1 mole of oxygen gas, molar mass 32 at temperature T. The pressure of the gas is P. An identical vessel containing 1 mole of helium gas, molar mass 4 at temperature 2T has a pressure of. So according to ideal gas equation, we have the relation as PV equal to nRT. Now here it says both gases contain same moles of 1 mole. R is same for both. Here it says identical vessel means volume will be same, hence pressure will be proportional to temperature. Therefore, we can say pressure exerted by oxygen gas divided by pressure exerted by helium gas is equal to temperature in case of oxygen gas, which is equal to T, and here temperature in case of, let's say, helium gas is given out here as 2T, and pressure exerted in case of oxygen gas here is our P divided by pressure in helium gas is being asked to calculate. So this T and T cancels out, so pressure exerted by helium gas comes out here as 2P. Hence we can say 2P means option number 3 is the correct answer, hence 3 is our answer.
Hello, we are given the question, and the question says the average translational energy in the RMS speed of molecule in a sample of oxygen at 300 Kelvin are 6.21 into 10 to the power minus 21 joules and 484 millimeter per second. Right? So the corresponding values at 600 Kelvin are what? Since VRMS is equal to root over of K 3 kBT by M, right? 3 kBT by M. So from this, VRMS is proportional to root over of T, right? So energy would be proportional to T. So we have this equations 1 and 2. So first of all, we will use 1. So from 1, what we can say is that VRMS, right? So initially, what we have initially, T1 is 300 Kelvin, T2 is 600 Kelvin. E1 is 6.21 into 10 to the power minus 21 joules, and V1, let us say V1 is equal to 484 meter per second, right? So V2 by V1 would be equal to T2 by T1 whole root, right? So from here, what we can say, V2 to be equal to root over of, here it would be 600, right? So 600 by 300 into V1, right? Since V1 is 484, right? So from here, V2 would turn out to be equal to 68. So V2 would turn out to be equal to 684.7 meter per second approximately, right? So this would be the velocity. Now, using second equation, we get E2 by E1 to be equal to T2 by T1. So from here, E2 would be equal to 600 by 300 into E1, right? So that is 6.21 into 10 to the power minus 21, correct? So this would be equal to 12.42 into 10 to the power minus 21 joules, right? 12.42 into 10 to the power minus 21 joules and 968 meter per second. So any of the options we can cut and we can correct it to be equal to 684, right? So option A is our answer. Thank you.
Hello everyone. So the question is given that the question is three closed vessels, that is A, B and C, are at the same temperature T and contains gases which obey the Maxwell distribution of velocities. Vessel A contains only oxygen, B only nitrogen, and C a mixture of equal quantities of O2 and N2. If the average speed of the O2 molecules in vessel A is V1, that of the N2 molecule in vessel V is V2, the average speed of the O2 molecules in vessel C is. Okay. So basically there are three vessels, one in vessel A. Suppose there are three vessels, vessel A, vessel B and vessel 3 C. In this vessel there is only oxygen, in vessel B there is only nitrogen, and C is the mixture of O2 plus N2, but the same amount of oxygen the vessel A have. Okay, oxygen of in C vessel is equal to the oxygen in vessel A. Okay, this is given in the question. Now the velocity in of oxygen molecules is V1 in vessel 1, and the velocity of vessel B of N2 molecules is V2, and they are asking the average speed of V average of oxygen and in the vessel C, and mass of the oxygen molecules is m. Okay, now, and these vessels contains oxygen, nitrogen, or oxygen plus nitrogen are obey the Maxwell distribution of velocity. Now basically Maxwell distribution of velocity is basically the graph between the velocity and number of moles. So this is our velocity and this is our number of moles. And this graph is basically like this. Okay, at this point our V is maximum. V maximum, when number of moles are maximum, our velocity is also maximum. Now the average velocity is given by the formula V average. Average is given by under root 8 kt upon pi m. In from this formula we can say that our V average is depend on two things. First is temperature and second is mass. V average is directly proportional to root of temperature first, and second thing, V average is also inversely proportional to the root of 1 upon m. Now the temperature for all the vessels are same, so this is not useful for us. Okay, we will going to use only this, that our V average is directly proportional, inversely proportional to the 1 upon n root of 1 upon m. Now it is given that mass of O2 will be same in A and C, because in the question they are giving that vessel C is containing the same amount of oxygen the vessel A contains. That means the mass of oxygen in vessel A is equal to the mass in vessel C. That means when mass is same, that the V average, our velocity, is also same. V average of O2 in C vessel is equal to the V average of O2 in A. Okay, so this is our answer. Okay, thank you.